Hi, today we are going to see about amplitude shift keying in digital communications. Amplitude shift keying is a type of amplitude modulation which represents the binary data in the form of variations in the amplitude of a signal. Any modulated signal has a frequency carrier. The frequency is a high frequency. The binary signal when ASK modulated gives a zero value for low input while it gives the carrier output for high input. The ASK modulator block diagram comprises of the carrier signal generator, the binary sequence from the message signal and the band limiter filter. The carrier generator sends a continuous high frequency carrier. The binary sequence from the message signal makes the unipolar input to be either high or low. The high signal closes the switch allowing a carrier wave. Hence the output will be the carrier signal at high input. When there is low input, the switch opens allowing no voltage to appear. Hence the output will be low. This is the block diagram of ASK modulator. The band limiting filter shapes the pulse depending upon the amplitude and phase characteristics of the band limiting filter or the pulse shaping filter. The first sequence is the input binary sequence, which is in the digital form. After ASK modulation, we get the ASK modulated output waveform as mentioned below diagram. For carried wave, the input is high, and for zero input there is no carrier wave present in the signal. ASK demodulator. There are two types of ASK demodulation techniques: asynchronous ASK demodulation and synchronous ASK demodulation. The clock frequency at the transmitter when matches with the clock frequency at the receiver is known as synchronous method, as the frequency gets synchronized. Otherwise it is known as asynchronous. The block diagram of the asynchronous ASK detector is shown in this figure. The asynchronous ASK detector consists of a half-wave rectifier, a low-pass filter and a comparator. The modulated ASK signal is given to the half-wave rectifier which delivers a positive half output. The low-pass filter suppresses the higher frequencies and given an envelope detector output from which the comparator delivers a digital output. The synchronous ASK detector block diagram is given in this slide. Synchronous ASK detector consists of a square law detector, low pass filter, comparator and voltage limiter. The ASK modulated input signal is given to the square law detector. A square law detector is one whose output voltage is proportional to the square of the amplitude modulator input voltage. The low pass filter minimizes the higher frequencies. The comparator and the voltage limiter helps to get a clean digital output. The binary ASK or on-off keying. Although we can have several levels of signal elements, each with a different amplitude, ASK is normally implemented using only two levels. This is referred to as a binary amplitude shift keying. In on-off keying, bit 0 is represented by the absence of a carrier and bit 1 is represented by the presence of the carrier. The output waveforms for the binary ASK on-off keying is given in this figure. The advantages of ASK is the ASK transmitter and receiver are simple to design, and amplitude shift keying needs less bandwidth than frequency shift keying. The disadvantage of ASK is ASK transmission can be easily corrupted by noise. Early telephone modem ASK is used to transmit digital data over optical fiber or some of the applications of amplitude shift keying. These are the assessment questions. First one is, what is amplitude shift keying? What is the application of amplitude shift keying? What are the advantages of amplitude shift keying? Is amplitude shift keying is digital? It is some of the assessments questions. Thank you.